Hello everyone, I am Suresh, Assistant Professor in Department of Electrical and Electronics Engineering from Chaitanya D2B University. Let us have a small discussion on testing of the transformers. Transformer is a static device. It has two windings. The winding which is connected to the electrical supply, that winding is called as primary winding. The winding which is connected to the load terminals, that winding is called as secondary winding. Here I want to measure how much efficiency of the transformer, voltage regulation of the transformer, and equivalent circuit parameters of the transformers. To find these parameters, we will conduct open circuit test and short circuit test on the transformers. Then let us come to open circuit test. This open circuit test is conducted to the low voltage side of the transformer, and high voltage side is open circuited. You may have doubts why we have to conduct open circuit test on high voltage side of the transformer. You can conduct open circuit test on high voltage side of the transformer also, but we need large rating of voltage source and large rating of measuring devices like voltmeter, ammeter and wattmeters. We will consider a example. If you wanna conduct open circuit test on 11 kV by 400 kV transformer where high voltage side is 400 kV. If you conduct open circuit test on 400 kV, you can require voltage source of 400 volts and measuring devices of voltmeter and ammeter. Where voltmeter ammeter doesn't measure that much kV values, kilovolts. So we have to consider instrument transformers instead of voltmeter and ammeter. So to avoid these problems, we will conduct open circuit test on low voltage side of the transformer. And this open circuit test is conducted at rated voltage of the transformer. For 11 kV by 400 kV transformer, we have to supply 11 kV to the low voltage side of the transformer. And this test is used to measure shunt to branch parameters of the transformers. Those are also called as magnetizing parameters, that is R0 and X0. It is mathematically expressed as where resistance R0, no load resistance, is ratio of open circuit voltage to core component current, that is V0 by IC, and leakage reactance X0 equal to open circuit voltage divided by magnetizing current, where open circuit voltage is high and it is nearer to the rated voltage. This open circuit measures iron losses of the transformers. You may have doubt why it is always giving iron loss of the transformer only, why it doesn't measure copper loss of the transformer. The balance equation for transformer is, whatever machine it is, the balance equation for machine is input power equal to output power plus losses. The major losses in the transformers are iron losses plus copper losses, where iron losses also called as fixed losses, constant losses and permanent losses in the machine, where copper losses is called as variable losses, heat loss. Then input power is defined as output power plus iron loss plus copper loss. For open circuit test, voltage is high but current becomes 0. Why current equal to 0 for open circuit test? Open circuit network always offers high resistance in the path, so R equal to infinity. According to Ohm's law, I equal to V by R. If R tends to infinity, then I equal to 0. If current equal to 0, then copper loss is directly proportional to current, then copper loss equal to 0. Then similarly, the output power of the transformer, V2 I2 cos phi becomes 0. Because I2 equal to 0, then the product V2 I2 cos phi also 0. So it is clear that where input power is iron loss, then we are giving power to the transformer, but we are not getting any output power. Simply machine is consuming the power, absorbing the power. That power is magnetic core is consuming the power. That is referred as iron loss in the transformer. Next, we have to go to the short circuit test. This test is conducted on high voltage side of the transformer, and low voltage winding of the transformer is short circuited. Now we have to conduct this test on low voltage winding of the transformer also, but needed large rating measuring devices. To avoid that one, we will conduct short circuit test on high voltage side of the transformer and low voltage side is short circuit. Yeah, the circuit diagram are shown in the figure. This test is conducted at rated current of the transformer, and this test is used to measure series branch parameters in the transformers like equivalent resistance and equivalent reactance of the transformers. Mathematically, it is defined as ratio of copper loss to short circuit current, where R equivalent is ratio of copper loss to square of the short circuit current, where short circuit current is rated current. As we know, impedance Z is combination of resistance and reactance. Z equal to R plus JX, where Z equal to square root of R square plus X square. Then X is becomes square root of Z square minus R equivalent square. And this short circuit test is used to measure copper losses in the transformers. Yeah, you may have doubt why it is measuring only copper losses in the transformer, why it is not measuring iron losses of the transformer. Yeah, in short circuit test, voltage equal to 0 because the resistance equal to 0, then according to Ohm's law, V equal to I into R, then R tends to 0, then voltage tends to 0. If voltage equal to 0, then iron losses is directly proportional to square of the voltages, so iron loss becomes 0. Similarly, the output power in the transformer V2 I2 cos phi also 0, because V2 equal to 0, then product of output power V2 I2 cos phi also 0. So transformers gives only copper losses in the from the short circuit test. Finally, we have to conclude this session is we have to find efficiency of the transformer. The formula to calculate efficiency of the transformer is ratio of output power to input power, where input power is output power plus iron losses plus copper losses. We will find iron losses from the open circuit test and copper losses from the short circuit test. In next coming videos, we will discuss to find maximum efficiency of the transformer and voltage regulation of the transformer. Thank you.